All right. Here we are continuing in Chapter 3, Section 4. This is finding slope and rate of change. Slope can be defined several different ways. One way that we can define slope is that it's the steepness of a line, how steep something is. We can also do rise over run, and we can also say it's the ratio of the vertical change to the horizontal change. If you look down here, I've got them kind of summed up all on a row here. Slope can be defined as rise over run. It can be defined as the change in the y over the change in the x. And it can be also defined as the vertical change over the horizontal change. All right, so let's look at finding the slope between 2 points. Here's the slope formula. Slope is the same thing as the variable m. If you see the variable m, that means slope. And we're doing y2 minus y1 over x2 minus x1. And if you look at the 2 points, this is our first point. And as we have points in any ordered pair, the x always comes first, the y always comes second. So we've got the first x, so that's x1, and we have the first y, that's y1. Here's our second point. X is still always first in the ordered pair, and y is always second in the ordered pair, but this is our second point. So we're going to call this x2 and y2. So if we use this formula, all we need to do is plug in those numbers. y2 is 6, so I'll plug 6 in. y1 is 2, so I'll plug that in. x2 is 2, and then for x1 I'm going to plug in -4. As we do this, the numerator goes to 6 minus 2, which is 4. The denominator, careful here, we got minus and negative. This is like saying 2 plus 4. This gives us 4/6, and that can be reduced. So 4/6 reduces to 2/3. Okay. If we graph this, -4 and 2, you can put a point right there. 2 and 6, you can put right there. We can also do rise over run between here. So if we go from one point to the other, let's say we start here, we have to go up 4, so that's +4, and we have to go to the right 6 spaces, so that's +6. So if we do rise over run, here we've got a rise of 4, a run of 6. We reduce that, we've got 2/3. So by graphing and doing rise over run, we got 2/3, and by using the slope formula, we also got 2/3. So that's two different ways you can find slope given the points. Okay, so that's finding positive slope. For negative slope, again, here's our 2 points. This is going to be our x1. This is going to be our y1. This will be our x2. This will be our y2. So all I'm going to do now is take that slope formula and plug the values in. y2 is -4. y1 is 6. x2 is 5. x1 is 0. We simplify the numerator. -4 minus 6 is -10. The denominator, 5 minus 0, is 5. -10 divided by 5 is -2. If we graph these over here, 0, 6 is right here. 5, -4 is right here. And if we go from one point to the other, say we start here, we have to go down 10, and we've got to go to the right or over 5. So if we did rise over run, we've got negative 10. Let me clean that up a little, got a mess there. We've got negative 10 for the rise, and we got 5 for the run. Negative 10 divided by 5 is negative 2. So by doing rise over run, we got negative 2, and by doing the slope formula, we also got negative 2. So that's with negative slope. Let's look at finding the slope of a horizontal line. Again, if we use the slope formula, going up here, this is our first point, so this is our x1, this is our y1, this is our second point, so this is our x2, this is our y2. So I'm just going to plug those in. y2 was 4, x1 was also 4, x2 is 4, x1 is a negative 2. So in the numerator we've got 4 minus 4, which is 0. And the bottom, again, we're subtracting a negative, so that's like saying 4 plus 2. We've got 0 over 6, which simplifies to 0. So the slope of this line should be 0. If we graph these points, negative 2, 4, it's right there. 4, 4 is here. It doesn't matter what point we start at. Let's say I start at this point. We don't go up or down, so our rise is 0. All we do is we go to the right 6 spaces. So if we do rise over run, our rise was 0 and our run was 6, and that gives us 0. So by graphing, we get a slope of 0. By using the slope formula, we've got a slope of 0. Okay. And that's finding slope of a horizontal line. Let's look at finding slope of a vertical line. This is the last example using the slope formula. So here is our first point. That's your x1 and your y1. So your first x, your first y. Here's your second x and your second y. So I like to identify those first and then plug them into the formula. Y2 is 1. Y1 is 5. X2 is 3. X1 is also 3. So when you simplify this, in the numerator, 1 minus 5 is negative 4. And 3 minus 3 is 0. Well, we can't break anything into 0 parts. So this can't be done, so we say this is undefined. So it has undefined slope. If we do this over here, doing rise over run, if we graph one point, the first point 3, 5, and the second point at 3, 1, and if we do rise over run, well, if we start at this point, we go down 4, and we don't go left or right, so our run is 0. Well, we can't divide by 0. We have the same problem here, so this is undefined. Alright, so finding the rate of change. Here is a table showing time for painting a house and how much it costs. We want to find the rate of change in cost with respect to time. Rate of change basically is when you compare a change in one quantity to a change in another. So we're going to compare the change in time to the change in the cost. So if we look at this here, that's like an ordered pair or a coordinate. So we can say 490. If you look at this one, that's like another ordered pair. So we got 6 and 135. Okay. So this is like our first point, so that's our x1. This is our y1. This is our x2. This is our y2. So if we use that slope formula of y2 minus y1, all over x2 minus x1. All we need to do is plug those numbers in. y2 was 135. y1 was 90. x2 was 6. x1 was 4. So as we do this, 135 minus 90 is 45. 6 minus 4 is 2. This simplifies to 22 and a half, but in terms of money, we're looking at $22.50 per hour.